Now we're coming to one of my favorite parts, I would say. This is the Terrigopalatine ganglion and the Terrigopalatine fossa. One reason is because this provides to be a very challenging dissection in lab. It is incredibly hands-on because our target is very deep within the human body, or very deep within the skull. It's all the way in here. Okay? So, first of all, where is this interesting little ganglion situated? This ganglion is actually located in an area called the Terrigopalatine fossa. And that is basically just a small little conical space which is below or inferior to the apex of the orbits. And there's one on the left and one on the right side. It lies between the pterygoid process of the sphenoid posteriorly and the posterior aspect of the maxilla anteriorly. The medial wall of this space is formed by the ghosted perpendicular plate of the palatine bone. The roof of the Terrigopalatine fossa is not really complete. It's formed, at least in part, by the greater wing of the sphenoid bone, and our sphenoid bone is going to be sitting right here. The floor of the Terrigopalatine fossa will be formed by a structure called the pyramidal process of the palatine bone. So, how can we get to the Terrigopalatine fossa? Well, in lab that is different than the approach if we were to do this non-destructively. In lab, what many people do is you hemisect the head right down the midline, make a median or a slightly off midline section, then you can get to the Terrigopalatine ganglion and fossa from the midline. There are communications with the Terrigopalatine fossa through an opening which is called the pterygomaxillary fissure. Medially, we can get there via the nasal cavity through the sphenopalatine foramen. You may recall that this is a foramen through which the sphenopalatine artery passes. Anteriorly and superiorly, there are communications with the orbit through the inferior orbital fissure, where we also see the V2, the maxillary nerve, which then turns into the infraorbital nerve pass. Posteriorly and superiorly, well, we have here the region where the maxillary division of the trigeminal nerve exits, so that is going to be the foramen rotundum, the round hole. And what do we find in the Terrigopalatine fossa? Well, we can find in here the maxillary nerve, with which the nerve of the pterygoid canal is associated, as is the Terrigopalatine ganglion. And we'll find the terminal or third part of the maxillary artery going through here as well. It's not shown right now because we only have the nerves highlighted, but you'll actually find the terminal part of the maxillary artery and its branches together with its veins. Your maxillary nerve, highlighted now, is going to enter the Terrigopalatine fossa posterior superiorly through the foramen rotundum and runs anterolaterally. You can see it doesn't run completely straight, but slightly laterally as well. Within the fossa, it gives off a branch that is called the zygomatic nerve, and that divides again into smaller branches called the zygomaticofacial and the zygomaticotemporal nerves. Also, the maxillary nerve gives off two nerves from which there hang this ganglion. Those two nerves, I do not think they're highlighted right now. These are called the Terrigopalatine nerves. And those are actually the nerves from which this ganglion is, in real life at least, suspended from V2. These Terrigopalatine nerves are going to be the ones that help convey general sensory fibers from the maxillary nerve that then pass right through the ganglion. They don't synapse or anything. They pass right through the ganglion without synapsing and supply the nose, the palate, the tonsil, and the gingivae. The maxillary nerve then will leave the Terrigopalatine fossa through the inferior orbital fissure and come out right on the face, just about here. which is where it contributes to our typical innervation pattern for V2. Now, where do all those fibers to the Terrigopalatine ganglion come from, and what is its function? Well, one of the functions of the ganglion is to provide the parasympathetic fibers that we need to make tears, so for the lacrimal gland. So those fibers will actually be originating from the facial nerve, and the facial nerve then gives off a branch called the greater petrosal nerve. The greater petrosal nerve, highlighted now, as you can see, travels mostly anteriorly and then goes a little bit further down and emerges with another nerve that is coming from inferiorly. And the nerve it merges with from inferiorly is the deep petrosal nerve. So the deep petrosal nerve will actually come from the superior cervical ganglion ultimately, and it will carry postsynaptic sympathetic fibers. The greater petrosal nerve, as it comes from cranial nerve 7, will carry with it these fibers that will also have parasympathetics heading for the Terrigopalatine ganglion. The merging of the greater petrosal nerve and the deep petrosal nerve leads to the formation of the Vidian nerve, which is also called the nerve of the pterygoid canal. So this nerve now has both postsynaptic sympathetic fibers, the synapse in the superior cervical ganglion, and presynaptic parasympathetic fibers that came via the facial nerve. Well, these fibers all travel to the Terrigopalatine ganglion. As I've already said, the sympathetic fibers just travel right through. The parasympathetic fibers, however, will synapse in this fibers that are perfect because they will then actually travel via a few relays that I will show you in more detailed diagrams to, for instance, the lacrimal glands and other glands in your nasal cavity. Now I've added in the lacrimal gland, and here's the lacrimal nerve, which is technically just a branch of V1. However, the fibers, the parasympathetic fibers, got to V1 or got to the lacrimal nerve via a relay on a branch coming from V2, called the zygomatic nerve. Okay, so here we switch to our first detailed picture. We can see over here the Terrigopalatine ganglion, and the Terrigopalatine ganglion is hanging down from V2 via these two Terrigopalatine nerves. So, if we follow this backwards, we can see down here the deep petrosal nerve with postsynaptic sympathetics joining the greater petrosal nerve that comes from 7 with presynaptic parasympathetic fibers. They will form this short nerve that runs through the pterygoid canal, which is called the nerve of the pterygoid canal. It's also referred to as the Vidian nerve. Yeah, those are synonymously used with each other. Here, the sympathetic fibers pass through, parasympathetic fibers synapse in here, then get relayed via several different branches, including the zygomatic nerve and the lacrimal nerve, and, for instance, go to the lacrimal gland here. Now we can have a look at this diagram. This one will focus on the parasympathetic fibers. So we have our maxillary nerve that has general sensory fibers, and we have the greater petrosal nerve with presynaptic parasympathetic fibers. They travel through the pterygoid canal, form the nerve of the pterygoid canal, which has parasympathetic and sympathetic fibers. Parasympathetics synapse in here and travel to the lacrimal gland, for instance, and also travel to other regions like in the nasal cavity or the palate via posterior superior nasal nerves, the greater and lesser palatine nerves, and so on. Over here, now we see the pre- and postsynaptic parasympathetic fibers. Presynaptic parasympathetic fibers via the greater petrosal nerve. Synapse in the Terrigopalatine ganglion. And here you can see the distribution to the nasal cavity and the palate, to the pharynx, also to the nasal cavity via the sphenopalatine nerve, and then all the way up via ganglionic branches, via the zygomatic nerve, the lacrimal nerve, to the lacrimal gland to make tears. This whole concept is really, really important because it is a question that is frequently asked. Where does the innervation for the lacrimal gland come from? And what parts in this sequence could you lesion to prevent the formation of tears? Not that you would want to do that, but it can tell you a lot about anatomy and about neurophysiology if you understand what functions can be interrupted that would lead to a loss of lacrimation. If you were to cut the communicating branch to the lacrimal nerve, you would lose tear production on one side. If you had a tumor compressing the Terrigopalatine ganglion, you would lose unilateral tear production. Even if you had a lesion to the greater Petrosal nerve or the facial nerve at the internal acoustic meatus, you would lose tear production. However, you wouldn't lose saliva production. You would have decreased saliva production because you might recall that the sublingual and submandibular glands, they're far away from here technically, they also get their innervation via the facial nerve. The parotid glands still make saliva though, so you would still have saliva. Last image. For our general sensory fibers, we know the great sensory nerve is the trigeminal nerve, has V1, V2, and V3. We have general sensory fibers, they come here, these are they're actually GSA fibers, so have to come from the periphery, travel this way, pass through the ganglion, and go back to the trigeminal ganglion. We have the sympathetic fibers that have actually traveled upwards. Remember that the spinal cord only extends from T1 to L2. Above that you don't have any intermediolateral cell column or white Ramey communicans, so you would actually have postsynaptic fibers traveling upwards here. Then these have synapse in the superior cervical ganglion. They travel via the deep petrosal nerve, merges with the greater petrosal nerve to the nerve of the pterygoid canal, aka Vidian nerve, and the sympathetic fibers will just pass right through. No, sympathetic fibers don't do anything in the Terrigopalatine ganglion. Yeah, that's a trick question. What do? Nada, nothing. Yeah, they just pass through. It's the same if you think about the ciliary ganglion that's very close to the eyeball. The ciliary ganglion is a synapse place for parasympathetic fibers, in that case actually from the oculomotor nerve, but sympathetic fibers will travel through, yeah, but do nothing in it. That is the Terrigopalatine ganglion in rapid fire.